In this video I'm looking at the third order intermodulation on the receive side of this box. It's an Anglian 3 transverter by G4DDK. I have two signal generators separated by 20 kilohertz. Each of them goes to one of these boxes. This is a dual circulator with very good isolation. That prevents the signal generators from seeing each other. They are connected to this box here, which contains 70 ohm coaxial cables to form a hybrid that isolates these two signals from the two circulators from each other. And then there is a dummy load in one of the outputs, and from the other the signal goes into this attenuator. And as you can see, I have set it to 0. The cable from the attenuators right now go into a spectrum analyzer, and you can see here that the level is 0 dBm. And I turn the attenuators 4 steps, 1, 2, 3, 4, and now I can read minus 40 dBm. And I move the cable to the transverter. The output of the transverter is connected to this RF space SDR IP. I have added 30 dB of attenuation because that's required when the signal is at maximum. I have calibrated the S-meter to show the minus 40 dBm, which is the input signal at the moment. And the spectrum looks like this, and we can see some third order intermodulation here. I will measure the level of the signal and of the third order intermodulation with different settings on the attenuator. It's now minus 40, that's 30 and 20. And I will evaluate this and put on a paper. Here are the results. At different attenuator settings, this is the signal level I read for the two tones, and the level of the third order intermodulation product. I have then changed the attenuator on the SDR IP. It was 30 dB here, and here it is no attenuation, and then I can see the signal is approximately 30 dB stronger, and I can read the IM3, and I can do it also one step further on the attenuator. Evaluating the two-tone signal level here, the level of the third order intermodulation product here, and with attenuation 30 or attenuation 0 I get very nearly the same result, so I take the average. Using these columns, this one and that one, I can compute IP3, and at strong signal levels, one should expect somewhat irregular behavior, because IM3 is produced in several different stages in the mixer and in the amplifiers. And the phase relation could be a little bit different. But as the level goes down, I think the IM3 from one of the possible sources is going to dominate, and we would get a IP3 value that is the same regardless of the signal level. And that's the normal rule. IP3 should be extrapolated up from low levels, so it's from here or from here, and that we get somewhat different at very high level. That's not really IP3. So 4.8 or 4.9 minus 4.8 or minus 4.9 dBm is the IP3 I find for this unit.